Hello guys, welcome back to my channel. So in this video we have integrate 1 minus v over 1 plus v square. So here we would separate the numerators first, as in we'll separate 1 from v, so we can easily rewrite it as this. So by separating them into two fractions, I would have 1 over 1 plus v squared minus v over 1 plus v squared. You know, finding the LCM of these would give you the same thing back. So I'm not changing anything, I'm just making my work far much easier. And then in this case, I can easily write it as the integral of this minus the integral of this, as in this way, yeah. So that's when I'll be integrating two different sides together, or separately, and then eventually I will bring them together, whichever method works out. So, but then in this situation, I would be integrating my first side first. That would be integral of 1 over 1 plus v squared dv. So that's what I'll bring out first. Yeah. So whenever you see something like this in integration, any kind of integral value like this, and then the approach is this, the question is this, we always use tan to represent our variable, our value. So yeah, I will just add my v as tan x. So let's v equals tan x. And then by differentiating both sides, I would have dv equals x squared x dx, or dv over dx equals x squared x. Okay, so by making my dv this formula, I would have dv equals x squared x dx. So that's when I'll be going back to my equation. I'll replace my dv with x squared x dx, because now I'm integrating with respect to x. There will be no more v. Everything is just going to be x now. So, and then we have it as this. So after substituting, okay, said this already, we have integral of 1 over 1 plus tan squared x multiplied by x squared x dx. Now I've substituted every value into it. But then from our trigonometry, 1 plus tan squared x is always equal to x squared x. Maybe you should go back to that. I can remember, just like 1 plus cos squared x plus sin squared x is equal to 1. This is also x squared x, as in x squared x minus tan squared x is equal to 1. So by writing it, have this 1 plus tan squared x equals x squared x. How am I doing this? Is that I want to replace 1 plus tan squared x with x squared x. So as I would have this integral of x squared x over x squared x dx. Now these guys will cancel out. I'll have integral of dx. So when you integrate a constant, you have the variable. So when I integrate dx, I would have x as my answer, x plus my constants. So that would be x plus k subscript 1. So let's just call it subscript k, that's k1 for my first side. Now, but remember, I gave v a particular value. My v was tan x, so x wasn't part of our question, so we'd have to go back to v. So we're being given equation in v, so our answer has to be in v as well. So by finding the arctan of both sides, I would have arctan v equals arctan tan x. So I would have x equals arctan v as my answer. So x equals arctan v. So instead of writing x now, I'll just have arctan v plus k1 as the answer for my first side. Okay, so we are done with the first side, and then the second one, we integrate the other fraction. This is the fraction. So in this situation, we are looking at this. We know that the if I should differentiate the numerator, it can easily cancel out my. If I differentiate my denominator, rather, it can cancel out my numerator. So I can just say x equals 1 plus v squared. So then that would be dx over dv equals 2b. Okay, and then by making dv, sorry, formula, I would have dv equals dx over 2v. So I'll just substitute my dx over 2v into my equation now, because now we are integrating with respect to x. So we don't want to have v anymore. This v and the other v will cancel out. Let's see how it's going to work out. So we have integral v over x, because 1 plus v squared is now x. Just watch the other x out to cancel out, times dx over 2v. Now the upper v and the lower v will cancel out, and that will just give me 1 over 2x. So I can write this and then bring out my coefficients, and I can just put it at the back of my integral. I have 1 over 2 integral of 1 over x dx. So from our integral rule, the integral of 1 over x dx is always in x. It's like the differentiation. If you differentiate in x, you'd have 1 over x. So when you go back to integrating over x, you have in x. So I would have it here as 1 over 2 in x plus like k plus constants. But then x equals 1 plus v squared. Our question we're being given in terms of v and not x, so we have to go back to the terms of v. That would give me 1 over and 1 plus v squared plus k2. Now I call it constant k2. So we're done. You can say we are 90% done with these. So all we have to go back to our question. Okay, so we have both sides already, so let's just put them into each other and subtract. So we have it as this. Just said my k, let's k1 minus k2, because if you check this, it's subtracting out. Let's just call them k because they're all constants. So k1 minus k2 should give me another kind of constant. So let's just simply call everything k, and then I would have arctan v minus half n 1 plus v squared plus k. Yeah, so this is our final answer. Yeah, and thanks for watching, guys. If you want more of this video, please subscribe to the channel and stay tuned. Bye.